All right, last one. Okay, I want to do the one again that equals 0, so the negative x squared plus 9. I'm doing a different color because I have to go way up here for some of these. Okay, what questions do you have before we make our last connection? What do you got? Stay with me, you guys are doing great. So many connections this unit. Any questions? Yes or no? No, we're doing all right? Yeah. We're on D, so I put the one that equaled 0, negative x squared plus 9. For D.
For C.
Oh, for C? Always do the one that equals 0. So I would have done, for C, I would have done 2x minus 3. The one that equals 0. Natalie, does that make sense? Yeah? Okay. Okay, so let's kind of put it all together if there's no questions on what we've done so far. Okay? So how can the discriminant be seen on the graph? Can I have someone raise their hand and tell me how can I see the discriminant on the graph? Okay, why don't we take a look here? How could I tell based on the graph that C, how could I have told that C had a negative discriminant just based on the graph? That's a good guess. Nope. That's why I know like the one in front of the x squared is negative. Okay? Okay? How do I know that C would have a negative discriminant based on the graph? Think about what do negative discriminants mean? Vess, can you put your book away? I know I can tell you're at the end. It's got to be a good one. Darius? It doesn't have an x-intercept. That's why, right? Negative discriminants mean imaginary. So if I was just given a graph and nothing else, I should already know that that would have a negative discriminant because it doesn't have any x-intercepts, right? Okay, let's look at B. How could I tell if I was just given that graph that B's discriminant was 0? Perfect, because the end of the U shape is the x-axis. Perfect. Okay? How could I tell just based on the graph for A that it would have irrational answers, meaning a discriminant that's not a perfect square? How could I tell just based on the graph that my discriminant is not a perfect square? Taylor?
The x-axis, the numbers on the x-axis are whole numbers.
Does that make sense? The x-intercepts aren't whole numbers, so my discriminant couldn't have been a perfect square. You guys are doing great. If I look at D, that's the opposite. See how my x-intercepts are whole numbers? Oh, that's an eraser. Are whole numbers? So then that should tell me my discriminant is a perfect square. So how can the discriminant be seen on the graph? Yes, the x-intercepts. And what can we tell about a graph of a quadratic just from the discriminant? The x-intercepts. Okay, and number 1, all we're going to do is say the number of types of solutions, or like the type of discriminant based on the graph. Okay, so first of all, on number 1, does it have x-intercepts?
Yes.
Yeah, so I know my discriminant's not going to be negative, right? Does it have 2 x-intercepts?
Yes.
So I know my discriminant's not 0. Okay, are my x-intercepts whole numbers? No? You guys agree? So that means that my answers are irrational. So what type of discriminant? If my answers are too irrational because the x-intercepts aren't whole numbers, then what type of discriminant? Positive, non-perfect square. Good. That's the longest one. So, like, in terms of like how much to write. So we got it out of the way. All right, number 2. Does it have x-intercepts?
1.
Just 1. Because my x-intercept is at the very end of the U-shaped thing, right? So what's my discriminant?
0.
Yes. 1 rational. So my discriminant is 0. Okay, number 3, does it have x-intercepts? No. So that means it must have had 2 imaginary solutions, right? Peyton, let me get you the homework. 2 imaginary solutions, right? So then what type of discriminant?
Negative.
Negative. Yes. Thank you. Last one. Two x-intercepts, are they whole numbers? So that means there's 2 rational So what type of discriminant? Perfect. Good job, you guys. I know that was a big lesson. Did great. A positive perfect square. Okay. I'm going to hand out your homework. Next time is the review.